Welcome students. This is Ravi Shankar. See, in this video, let us start with some of the example problems. After dealing with the example problems, we will be going with the next topic of that first lesson, electrostatics. Already, we have studied up to electrostatic shielding. And in our previous videos, we have gone with example problem 1.7. So let us start with the next problem, that is example number 1.8. See, what is that problem? Come on, go through that problem. A block of mass m and a positive charge q is placed on an insulated, frictionless, inclined plane as in figure. An uniform electric field E is applied parallel to the inclined surface such that the block is at rest. Calculate the magnitude of the electrical field E. So that was the problem. The diagram was being given an inclined plane of height h, and the angle of inclination is theta. Length of the inclined plane is given as L. Over that, a body of mass m is being placed. Now, along the inclined plane, an electrical field E is applied. So, by using this, we have to calculate the value of this electrical field E. In order to keep this mass to be at rest position. So that is what I have started to write. In order to keep the mass at rest, what is the electrical field E? So I will be drawing that diagram again and I will be explaining. See, what is the problem now? We are having what? We are having an inclined plane. So the inclined plane is given like this. The height of the inclined plane is h. Length of the inclined plane is L. Angle of inclination is theta. Over this, you are having a body of mass m. Now, I can say that along this direction, that is parallel to that of the inclined plane, an electrical field E is applied, and you have to calculate what is the value of the electrical field. Now, in order to keep the mass at rest, what is the electrical field? See, when you are considering the mass over this inclined plane, we can consider, or we can say, there are three forces acting on the mass. There are three forces acting on the mass when an electrical field is applied. What are the three forces acting on the mass? Number one, see, when you are considering the mass to be placed here, the gravity, acceleration due to gravity is acting on that mass, which makes its force to act vertically downwards. So, the force due to gravity, or we can say the gravitational force mg, is acting vertically downwards. This is one of the force. What is the second force? Normal to this inclined plane, you can consider the second force, what we are calling it out as the normal force N. It was given that this body of mass m is having a charge q. Now, if this body of mass is having a charge q, then this mass is placed inside an electrical field which is acting parallel to that of this inclined plane. So the charge will be experiencing a force inside this electrical field, and the force experienced by the charge, we can write it out as E into Q. As we know, E is equal to F by Q, so F is equal to E into Q, acting in the same direction as that of the electrical field. So you are having three forces acting on this mass. One of the force due to gravity called to be gravitational force acting vertically downwards. Second one is the normal force which is acting perpendicular to that of the inclined surface. And the third one is the Coulomb force due to the applied electrical field, which is considered to be E into Q, acting along the same direction as that of the electrical field. So let us write what are the three forces acting on that. Number one, the first force is the gravitational force. Okay, the first force is gravitational force, and let us consider this gravitational force as m into g, acting vertically downwards, acting vertically downwards or vertically down. This is the first force. What is the second force? The second force is the normal force, which is acting perpendicular to that of what? Acting perpendicular to that of the surface. So the second one, I am writing it as the normal force, which is considered to be N, exerted by the inclined surface, that is normal to it, by the inclined surface, acting perpendicular to that of the surface. Let us consider the third one. What is the third force? We can say the third force as the Coulomb force on the charge Q by or due to the electrical field E in the same direction of the electrical field. In the same direction of electric field. So these are the three forces that were being acting on what? That were being acting on the mass M. In order to explain this, I am drawing an Freebody diagram. You might have studied it in your 11th standard by considering the mass as an point mass. So here I am considering the free body diagram. In order to represent these three forces, I am considering the mass as an point mass M. What are the three forces? On this point mass M, vertically downwards, you are having the gravitational force mg. Then perpendicular to that of the surface, you are having the normal force acting. It is called to be or considered to be N. And along the direction of the electrical field, you are having the electrical force due to electrical field called to be Coulomb force, which is EQ. So this is the free body diagram. Now, what I am going to consider is, in that same diagram itself I will be drawing, I am extending this normal. See, when you are extending this normal, it will be along this direction. If so, I can consider the angle between the vertically downwards and the normal drawn as theta, because here the angle theta is marked as along the inclined plane and the base. Angle between the two lines is equal to angle between its perpendiculars. For this horizontal surface, the perpendicular line is this mg. And for this, when you are considering this inclined plane, then the normal drawn will be along n. So angle between these two lines, okay, this one and this one, angle between these two lines is equal to angle between its perpendiculars. So this is also considered to be theta. Now what I am going to do, I am now going to resolve this mg into two perpendicular components. One of the component acting along the surface opposite to that of what? Opposite to that of the gravity Coulomb force. And another component acting perpendicular to that of this component, which will be along this direction. So one is considered to be the adjacent side of theta, and this component can be drawn here, so which is considered to be opposite side. Generally, this mg is resolved into two components. One is the horizontal component and another one is the vertical component, where both components are perpendicular components. So when you are considering this component which is parallel to that of the inclined plane, we are calling it out as mg sin theta, because that component is opposite to theta. Similarly, when you are considering the component parallel to that of or along the normal, then it is considered to be mg cos theta. The reason is the force or that component is adjacent to the angle theta. So mg is resolved into two components. One is mg sin theta, acting parallel to that of the electrical field but opposite to that of the electrical force. And another one is mg cos theta, opposite to that of the normal or perpendicular to that of mg sin theta. Now, from this it is very clear that this normal force is balanced by this component mg cos theta, and in order to keep this mass at rest, this Coulomb force EQ is balancing this mg sin theta. Or we can say the mass m is at rest. If the mass is at rest means the mass has no acceleration either in x-axis or in y-axis. So we can write, since the mass is at rest, since the mass is at rest, it has zero net acceleration. It has zero net acceleration either along x or we can write both in x and in y direction. Okay, clear? Since the mass is at rest, it is having no acceleration. That is what we have written it as zero net acceleration both in x and y direction. Okay, let us now consider the second law here. So now there is no, if this mass moves, the mass moves only along this inclined plane, that is along the x-axis alone. So I am applying the Newton's second law along the x-axis. So I am writing it here, applying Newton's second law along the x-axis or along inclined plane. Along x-axis, I can state, see EQ, which is acting along the positive x-axis, and one is along the towards right is positive. So EQ is acting in the negative x-axis. So we can write first of all the positive x-axis. See, when you are considering the positive x-axis, the positive x-axis we are having mg sine theta. Since it is along the positive x-axis, I am taking it as I cap minus along the negative x-axis you will be having EQ. So, or I can say this is plus and this I can write it out as minus I. Sum of these two, vector sum of these two is equal to 0. Or in the next step, I can say that I can write this as mg into sine theta I cap minus EQ into I cap is equal to 0. Or we can consider like this. Here itself I have told this EQ is balanced by mg sine theta. So that is what I am going to write here. So when I am considering the magnitude alone, mg sine theta is equal to, I can write it out as E into Q. What is our task? We are going to calculate what? We are going to calculate the value of E. Therefore, I can write the value of E as E is equal to mg sine theta divided by Q. So, this we are calling it out as the magnitude of the electrical field that is acting on that mass and of charge Q, so that that charge or that mass is considered to be at rest. So I can write from this result, it is clear that, you see, from this result, it is clear that electrical field E is directly proportional to the mass of the body, and electrical field E is inversely proportional to charge available in that body. So, what is the explanation that you can give? If mass increases, then amount of electrical field also, then amount of electrical field needed also increases, or vice versa. That is, if mass decreases, electrical field applied also decreases. Similarly, from this what you can write? If the charge Q decreases, then the electrical field E increases, which indicates that electrical field and charges are inversely proportional. If Q increases, then electrical field is found to get decreased. See, this equation can also be written in terms of H and L. See, we know that when you are considering this inclined plane, this is inclination angle theta, the length of the inclined plane is L, and the height is H. From this you calculate sine theta. Sine theta is opposite side divided by hypotenuse. So I can write this as H divided by L. Substitute in this equation. Therefore, E equal to M into G divided by Q, multiplied it with, instead of sine theta, you substitute this value, you will be getting it as H divided by L. This is another form of writing or getting the answer for this problem. This we are calling or considering it as the expression or the value of the electrical field. At value of the electrical field when you are having a body of mass m and charge q placed on the inclined surface. Hope you should have understood. So, this is problem number or example number 1.8. Now, let us move on to the next problem. What does the next problem means? The next problem is problem number 1.9. What is this problem number 1.9? You see, I will be getting the problem now. See, what is that problem? You can see the problem. The following pictures deposit the electrical field lines for various charge configurations. In the figure, identify the sign of the two charges and find the ratio Q1 by Q2. See, in this first figure. In figure number B, that is in the second figure, calculate the ratio of the positive charges and identify the strength of the electrical field at 3 points A, B and C. So this is point A, this is point B and this is point C. And figure 3, figure C represent the electrical field lines for 3 charges. If Q2 equal to minus 20 nanocoulomb, then calculate the values of Q1 and Q3. So these are the problems or diagrams that were being given. Let us consider one by one. What is the first problem? See, the first problem, here itself I will be writing the answer. See, for figure A, you are having two charges Q1 and Q2. You are asked to identify the charges. See, the electrical lines of force starts from Q2 to Q1. According to the properties of electrical lines of force, we have studied that electrical lines of force starts from the positive charge and terminate at negative charge. Therefore, here Q2 is positive and Q1 is negative. This is considered to be the first case. Then what is the second one? You are asked to calculate, for this question itself, you are asked to calculate what is Q1 divided by Q2. What is the ratio of Q1 divided by Q2? See, Q1 divided by Q2 is nothing but ratio of number of lines that is going out from the positive charge. Q1 is negative charge. So number of lines getting into the negative charge, and Q2 is positive, number of lines that is going out of the positive charge. So what is N2 and what is N1? N2 is number of lines going out because it is representing the positive charge. You see, you count 1, 2, 3, 4, 5, 6, again here 7, 8, 9, 10, 11, 12. So from Q2, 12 electrical lines of force is going out. So N2 is considered to be 12. What is N1? How many number of electrical lines of force is reaching Q1? See, from Q2 to Q1, 1, 2, 3, here are 4, 5, 6. So you will be getting it as 6 divided by 12, or you can get the answer as 1 divided by 2. See, 12 or see, what is Q2? Q2 is 1, 2, 3, 4, 5, 6 and 7, 8, 9, 10, 11, 12. I think in your book it was being given as 6 plus 6. Yes, it is correct. 6 plus 6. So you will be able to get it out as 6 plus 6. Almost again you will be having 3 plus 3. Here also you will be getting 6, isn't it? 1, 2, 3. Here 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So N2 is considered to be 18, not 12. So I am writing what is N1? N1 is due to Q1. The number of electrical lines reaching Q1 is 1, 2, 3, 4, 5, 6. So this is 6. But how many number of lines going out of Q2? See, from Q2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is 18. So I can write it out as 1 divided by 3. Or this 1 divided by 3, you can write it out as Q1 divided by Q2. Therefore, we can write on cross multiplication, Q2 is equal to 3Q1. So this we are calling it out as the ratio. Or you can write Q1 is to Q2 is equal to 1:3. So this we are calling it out as the first concept. or the first problem. What is the second one? See, what is the second? You just go through the second. See what I have considered in figure B. See, in figure B, calculate the ratio of two positive charges. Identify the strength of the electrical field at point A, at point B, and at point C. Okay, what I can write here? You see, how I can write here? See, let us consider this diagram. So let us find a place to write. Okay, let us write it on the right hand side or right end. See, first of all, they are asked you to calculate Q1 divided by Q2. So number of lines from both the positive charges. So this is also a positive charge. This is also a positive charge. So first of all, I am calculating number of positive or number of electrical field lines or number of electric field lines from both positive charges. From both positive charges, you just count and write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Here also you are having 18. So I can write the number of electric field lines for both the charges is considered to be 18. Then you can consider 18 each, you can write 18 each. Then you consider point A, point B and point C, where the electrical field is 0. See, from this diagram we can say the electrical field strength at point C is equal to 0, because in that area we can say in that area there is no electrical lines. No electrical lines. So electrical strength is considered to be 0. Electrical strength is considered to be 0 at point C. When you are considering A and you are considering B, A is said to have more number of lines crossing over than that of B. Since you just look at the diagram in your book also, since more number of lines are crossing, A than B, we can say electric field intensity or electrical field strength at A is found to be greater than that of electrical strength at B. At C already I have told, at C you can say that electrical field is equal to 0, since inside it you are having no electrical lines of force. Then what is the third one? The third one, you are asked to calculate the ratio between Q1 and Q2. You are asked to calculate what is the strength or what is the value of Q1 if Q2 is considered to be 20 nanocoulomb. See, let us consider what is the third one. You see, look at the problem. What is the problem here? See, when I am considering the problem, that is third one, figure C represent the electrical field lines for three charges. If Q2 is equal to minus 20 coulomb, calculate the value of Q1, Q1 and Q3. Okay, let us consider this diagram. See, when you are considering this diagram, you can calculate the number of lines that is coming out of Q1, number of lines that is entering Q2, and number of lines going out of this Q. See the diagram, there is a mistake. From Q3, it has to come to here. Okay. So I have to draw the arrow mark here. Okay. Now Q1 is positive, Q3 is also positive, but Q2 is considered to be negative. So you write, or we can write number of electrical lines or number of lines from positive charge, from positive charges. What are the positive charges? The positive charges are Q1 and Q3, 1, 2, 3, 4, 5, 6, 7, 8. Similarly from Q1, 1, 2, 3, 4, 5, 6, 7, 8. So I can write the number of electrical lines that is coming out of Q1 and Q3 is equal to 8 each. So I am writing it like this, 8 each. Number of lines reaching the negative charge. Number of lines reaching negative charge, or I can say reaching Q2. The Q2 is considered to be what? Q2 is considered to be negative charge. If so, here you will be having 8, here you will be having 8. Our total number of lines you are considering is 16. Now, what you can able to calculate? You can able to calculate what is the value of Q1 divided by Q2. So Q1 divided by Q2, I can write the number of lines in 1 divided by N2. What is the number of lines in N1 or Q1? It is 8. How many number of lines from Q2? It is 16. So I can get the answer as 1 divided by 2. Given, what it is given? If Q2 is equal to minus 20 nanocoulomb, then what is the value of Q1? See, you can substitute here. What is Q1? Q1 I have to calculate, divided by. What is Q2? Q2 it was being given as 20. If it is modulus, I can consider it as positive, is equal to 1 divided by 2. Therefore, what is Q1? So Q1 is equal to 20 divided by 2. So I can able to get it out as 10. So when you are considering Q1, Q1 is equal to, therefore Q1 is equal to plus 10 nanocoulomb. What is Q3? Already we have told Q1 is equal to Q3. So Q1 is equal to Q3. Both the charges are positive and the value is considered to be 10 nanocoulomb. This is what we are considering it as the problem number example 1.9. Hope you should have understood. For diagram, you please refer your book and count the number of lines and check which end is having more number of lines and which point is having more number of lines and which point is having less number of lines. Okay, let us see the remaining problems in the next video. Thank you.